Okay. Hello. All right, so we're going to get started. We're going to talk today about JavaScript futures. How many people were in John's talk yesterday? Did people say a few of you? Okay, yeah. So John gave a talk yesterday on the habits of highly successful developers generally and JavaScript developers. And that was sort of about some things in general about how you develop, how you look at patterns and some of the weird anti-patterns that seem to be built into JavaScript because JavaScript is what it is, right? So this talk is going to be more about the state of the language right now and where it is going in the coming months and years, and how do we figure out where we think it might be going, right? Because there's one thing that's true, as we'll talk about throughout this entire session, is JavaScript, despite all of its flaws and all of its problems, changes frequently. It wasn't always that way, but it is now. So we have to have a better way to kind of figure out where we're going. So my name is Jeff Strauss. I'm Jeffrey Strauss, Jeffrey, 2 syllables, Jeffrey Strauss on Twitter. I run a company called Arana Software. We're a consulting firm back in the United States. This is similar if you saw John's talk. I don't live in the same place as John, but very similar, near each other. Here's the United States. And I live in Missouri. And John lives over here in Kansas City. I'm from St. Louis, over there where the star is. So I like to say right in the middle of the country. The problem is John keeps yelling at me because he says that he lives closer to the actual center of the country than I do, which is true. But basically, right in the middle. And he and I, along with a couple other people, also are involved in a conference called the Kansas City Developer Conference, which is over in Kansas City, where he lives, but I do not. And this is it's like 200 miles across or something. So anyway, that's where I'm from. Now, the theme of the talk, as I said, is that JavaScript just keeps on expanding, right? It keeps on getting bigger. There's new features. There's new stuff. How do we keep up? So what we're going to talk about here is a kind of a 3-part thing. First of all, what is going on, right? What is going on? Why is it the way it is? Because JavaScript is crazy, right? And then how do we get a grip on what it is that is happening now and in the future in JavaScript? How do we get there? Now, a quick key that I always point out, because I want to make sure we're all starting from the same spot. There is JavaScript. There is ECMAScript. They are not the same thing. We use them interchangeably. And I will keep talking about JavaScript in this talk, even though I'm really mostly talking about ECMAScript, because even I use them interchangeably, but there's a distinction. But when we talk about ECMAScript, it's a standard. JavaScript is a language. It's an implementation, right? It's just a language that, in the case, I'm not a Java developer. So are most people in here, raise your hand if you are not a Java developer. A few. I know the 2 of you. Yes, a few people. So I don't have a Java background. I have a Java, and now I'm almost exclusively a JavaScript developer, and I come from a .NET background. But with JavaScript, we have a bunch of different environments that it's running in, right? And if you've ever built code for the web, as an example with JavaScript, you know that what's working great for you in Chrome may not work quite the same way in Firefox or in a mobile browser. You know for sure it does not work in Internet Explorer no matter what, right? And so the thing is, that's because all of these environments have their own implementation of the language. ECMAScript is the standard that the language is built upon. So a couple of years ago, ECMAScript 2015 was released. That's what we call ES6, right? That was really ECMAScript version 6 or ECMAScript 2015. It was a huge departure. If you've been writing JavaScript more than, say, the last 2 or 3 years, you know that a whole lot of stuff happened a couple of years ago in JavaScript. We got things like destructuring, classes, if there is any such thing as a class, which is a whole different soapbox that I'm going to try to avoid. But classes and promises and generators, all sorts of things that were new, import and export of modules, things that changed the programming paradigms we had in JavaScript. And teams are still kind of trying to catch up, and we're trying to learn all that stuff. It was a huge change. But then they went and they had an ECMAScript 2016. 2015 was the first release since 2009. So we figured we had plenty of time. But then they had new stuff in 2016. Then they had new stuff in 2017. So we're trying to catch up, but what we're really always worried about is ES Next. And ESNext is sort of this flexible term of whatever the next version of the language is going to be. Right now, ESNext is ECMAScript 2018, which will be finalized over the winter, this coming winter, and will be ratified by ECMA sometime in the summer. We'll talk about what that looks like a little later in the talk. But the key is, what I want you to think about when we talk about language features, even if you're still getting up to speed with stuff from 2015, from ES6, is that you can experiment with this stuff. Because just like when, and I had a conversation, again, I'm not a Java guy, I had a conversation with someone here, or it might have been in Belgium last week, where I heard that Java 9 actually did have some major changes that maybe had some backward compatibility stuff and some issues. But for the most part, think of the new versions of ECMAScript and JavaScript as being just the next version of a language. So it's not like saying, oh, I was using Angular, now I got to use React, or am I going to use Vue, and do I have to throw all my stuff away and learn something entirely new? These are all just new features. If something makes sense, use it, play with it, experiment with it. If the feature doesn't make sense for your team, who cares? Don't use it, right? Pick the stuff that works for you and evolve with the language in a way that makes sense. And normally this is an hour-long talk. We have a little less than that here. So we're going to jump right into what's current and new this year in 2017. The good news is 2016 there wasn't very much. But if you're used to the ES6 spec, last year in 2016 we added an exponentiation operator for taking like powers, right? Like 6 to the 9th power. We added an asterisk, like 2 stars as a mathematical operator for doing exponentiation. And there is an array.includes function now. So you can search for without using index of, you can actually search to see whether an array includes something using a proper function. That was it. So 2017, this is the stuff that's new this year. I've already said ES6, right? ES 2015, tons of stuff, way too much to handle. Last year and this year, much less. Right? There's really not that much that happened this year. I believe that 2018 is going to be similar. There will not be a ton of new stuff. I think we're going to start to see incremental changes every year where there's just a handful of new features that come into the language as we go. So let's look at what a few of these are. This is some of the stuff that's new this year that is part of the ECMAScript standard as of 2017. One thing is we have a couple of new static methods off of the object prototype. Who's familiar with object.keys? One person? I bet there's more than you that. 2 people? He always asks I know you are. John always asks the question, who is fundamentally, like philosophically opposed to hand raising? Is anybody opposed to hand raising? All right. Yes. See. All right. So object.keys has been around a long time. If you aren't familiar with it, you can take an object literal in JavaScript, pass it into object.keys, and you're going to get an array of the string values of the property names of the thing. And that's great, but it only gives you one half of the equation. You can get all the property names, you can get the keys out of your object. You can't get the actual values of those properties of the object. Object.values, which is new this year, fixes that. So take one of these days, I forgot again. One of these days I'm going to actually update the slide. Keller is my son, that's my kid. He's very precocious. He thinks he knows everything because he's an elementary school kid, and he likes to review my slides with me. So when I wrote this talk, it was a little while back, earlier this year. I had age 5, and he was looking at it, and he told me, he's like, Daddy, I'm 5.5. So I changed it. Now he's 6, so it's wrong again. So Keller, age 5.5. I take an object, I pass it to object.values. It's very simple. I get back the values. Now remember, with keys, if I said object.keys on this object, I would get the string name and the string age, right? We stringify those property names, but notice with values, we respect the types. People like to say JavaScript is a typeless language. It's not. It just is not a very strongly typed language, and there aren't nearly as many types. We do have numbers. We do have strings, right? So 5.5 will come back as a number. Not that exciting, but what that leads to is that there's an object.entries. Object.entries look like this. My daughter doesn't care because she's 2.5 now, and I still says 2. My daughter, Madeline. She's 2. I call object.entries, and what I get is a nested array. Right? So I'm getting an array of key value pairs. In some other languages, it isn't quite like this, right? You'll see some other languages, again, I don't know if this is how Java does it, where you'll see an an array of objects, right, where you'll have like a key property and a value property or something like that. That's not this. So JavaScript isn't quite that nice or that smart for us yet. It's a nested array where each array has the string name of the property and then the value. And another array that has the string name of the name of the property and the value. That's useful because who's familiar with iterables? Anyone remember iterables from ES6, right? So we can have things like for each loops now. I like to see he raises his hand. That's good. There was no way prior to this, no easy way to just iterate over an object literal. You can iterate over a map or a set or the weak maps and weak sets and arrays and a bunch of other iterable type constructs in JavaScript. But if you have an object literal, there's no way just to loop over this thing. But with object entries, we can. Right? With object entries, since this is going to return an array, object.entries returns an array of our key value pairs, I can iterate over it, and I just get a key value, one of the nested arrays, for each item in the loop. You could do this before, right? But you would have to use something like object.keys. You get the property names, and then you have to loop through, and you have to go back into your object and retrieve each value by property name, which was slightly less efficient and a little bit more code. So this is a more direct way to say you can actually loop straight through an object using object.entries. Does that make sense to everybody? Okay. You touched on this yesterday. John, people who saw John's talk, he briefly touched on this. Who's familiar with LeftPad? Who's heard the story of LeftPad? Yeah. So if you haven't, a couple of years ago, there's a guy who was a fairly prolific open source author, had a lot of packages out on NPM. One of them was LeftPad. He had a bunch of other packages. One, I can't remember what the name of it was, Crick or Click or something. There was another package that he had in NPM. And some startup came along that had the same name, and they noticed there was a name conflict. They complained to NPM about the name conflict. They said, this is our trademark now. You have a contributor on your site that has a conflicting name, and we need you to pull it down. And they basically requested, what the United States would call a cease and desist, to say they need to take the package down. The guy didn't like it. They argued, and the startup, with all the lawyers and with all the money, won. And so NPM went in and pulled the other package down. The author was upset, and he took all of his toys and went home, including LeftPad and all of his other projects. And the internet broke because React depended upon LeftPad. A whole bunch of libraries did, and nobody could build, even though it was 9 lines of JavaScript that any of us could have written ourselves, right? So first of all, that means that keep in mind that just because there is an open source package for you, if there's something you could really easily write yourself in 3 minutes, don't always just depend on somebody having done something. Yeah. They've resolved it. Yeah, they have. It's not as critical anymore. It's not. But it's one of those things that sort of thing happened. But the other point of all that is what that did at the time was the committee, the standards committee that's looking at the features, immediately said, oh, we don't have this in the language, right? There was no padding. It wasn't, the reason for something like LeftPad is because something as simple as string padding didn't exist. So while this doesn't seem like an important feature, it was an important thing to add because it wasn't there, and it was one of those things where we were depending upon some sort of little open source script to do something that A, should have been part of the library, should have been part of the language to begin with, and B, we could have written. So, string padding. This is, again, a very simple thing to use, simple thing in concept. Take a team of people, we have Jeff, Jay, Dennis, and we want to loop through them and log them out, and we get 3 strings. What if we want them to, say, be right justified? Right? We want to push them all and have them all be 8 characters long. It's very simple to use. You call pad start on your string with a maximum length and optionally a fill character or a fill string. Right? So the way that looks is I call p.padStart, give it a length of 8, and it will make all these 8, and it's going to pad the beginning with empty space because I did not provide a fill character or a fill mask, so the default is empty white space. So it's just going to push them over. But I can optionally provide a character, so I can say use a hyphen and fill it that way, and then I'm going to have hyphens in front of the names, or you can even use something like a string. I don't know why I put a bunch of ABs in front, but it'll take a pattern, and it's basically going to treat it as a mask, and it's going to put your strings right on top of it. And it's, here, for example, even though it's a ABABA, it'll just figure out where to stop. And so pad the string. Easy enough to use. Same thing here, I can use a full 8-character string. Now, there's also a pad end. Works the exact same way. Interestingly, what's the opposite of padding? Right? This already existed in JavaScript, even though padding didn't, except there is no trim start and there is no trim end. It's trim left and trim right. But it's pad start and pad end. Because it's still JavaScript, and they still don't really want it to make sense. All right? So, and the real reason beyond that is that the discussion amongst the committee when they were adding padding to the language was that they wanted to support more localized issues. So instead of saying left and right, they wanted us to be able to say start and end and let it be language agnostic, right? So for example, Arabic or Hebrew, right to left languages, you can simply say pad start, and if your application is running on someone's machine whose local environment is in Arabic versus someone who's in English or French, it will know to pad from the right because it's just going to look at start. So that was the real justification for changing the nomenclature of it. Right? However, they haven't done this yet. So it's still trim left and trim right. There's a proposal to do this. I don't know why they don't hurry it up and just get done with it. They haven't yet. When they do, they will almost certainly not eliminate trim left and trim right because they almost never remove stuff that would break backward compatibility. But just bear that in mind. Trimming is still not start and end. Okay? Okay, this was kind of the big one. All right, this is the big one this year, is async and await. Who uses promises instead of callbacks? Familiar with them? Okay. So, promises are great. I like promises. I use promises. They have drawbacks, still. They're way better than this, right? Promises are still way better than stuff like this. So you have some code, and we're gonna go get some data, then get some more data, process it, save it, and we have all these callbacks. And yes, there's nicer ways. They don't have to be, to John's point yesterday, they do not always have to be anonymous functions. You can use named functions, which makes this code look a little cleaner, right? But callbacks have always been difficult to work with in JavaScript. With promises, starting in 2015, we see code that looks more like this. There's also, .catch and things like that, right? So we can still have some error handling. But there are difficulties here still. There's still a couple of problems here for me. One, and there are ways around it for most of these things. One issue is these A, B, C, D, at least the way it's written here, are still local variables to each of these functions. So if I do something using chained promises like this, and I want to use A somewhere down here, it's gone out of scope. Unless I find some way to preserve A up above, I still don't have it in scope. So as I go step through step, I'm not necessarily preserving the data or information I need for later in my process. Another thing is it can be difficult to debug because the arrow functions themselves, once I get inside of whatever's in load other data, I can hit a breakpoint there. But if my issue is here, on this actual line, you can't really easily set a breakpoint and catch it during these anonymous arrow functions. So it can be hard to debug if you have problems. Okay. Async await takes asynchronous code and really makes it feel like you're writing synchronous code. Looks and feels, and in many ways executes like synchronous code. And there's two components to it. One is that the scope has to be an asynchronous scope. So to await anything, the scope that this await is used in must be asynchronous. So for example, this function await calls has to be declared as async. Without async, I cannot use the await keyword inside the function. It'll break. Okay. Async does a couple of things. It also, as we'll see, dictates how we return things back from it. And what await does is it simply does exactly what it sounds like. Is there a similar task-driven thing in Java like there is in C#? Is this paradigm sort of exist in Java at all? A little bit? Okay, in the future, yeah. So the way it works now in JavaScript is you can sit there. When we get here, this is still an asynchronous call. Load data is still asynchronous. But what we're going to do is instead of moving on, right, before await, what would happen here? We would call load data, and JavaScript is still single-threaded. It is still a single-threaded language. So it makes this call, and it moves on. And if you don't do something with load data, returning some sort of promise, it just gets forgotten about. We move on. With await, we don't. We hit this line of code, we call load data, and we say, I'm going to wait right here. I'll be here when you get back. Okay? Load data does whatever it needs to do. It returns something. And if it's wrapped in a promise, await unwraps it. So it's not even getting a promise back. Load data can be an asynchronous call that actually returns a promise. Await will sit there, take the thing, take whatever value that promise resolves to, and store that resolved value in A. If load data has an error, it will take whatever that error is, resolved out of the promise, and it will throw an exception. So we could also take this and we could wrap this in a traditional try-catch block that looks just like a try-catch around your synchronous code. Because if load data or any of these other asynchronous calls fails, it's just going to throw a standard-looking exception that you can catch and treat like any other exception handling. Right? Now, the advantage here is that async does something else as well. Async will wrap whatever it returns in a promise. So if we go back, console.log, say, okay, I do something and then save data and I just log out the result. That's fine. But it also, if I want, can return whatever D is. Maybe there's information coming back from my save call that I want to give some information to the user beyond just logging it to console. I need to return this. It will take D, and it doesn't return the real value of D. So remember, await unwrapped that promise so I can do whatever I need to do with it. When I then return D, it will rewrap it in a promise. So when I call await calls down here, I can use the traditional from 2 years ago, the traditional promise API and use a .then. I know it's kind of low down for people in back, but I can call await calls .then, and response will resolve to D. That works? Any questions about that? One place where I use it is the idea of multiple prerequisites. So take something, this is probably more ugly than it needs to be just to make the point, admittedly, but the scenario this kind of arose in for me was we were writing, John and I mentioned we were in that KCDC conference, and we were building a silly little console app in Node when we were going through our speaker submissions to kind of make some decisions as we started to parse through all the submissions for our conference. And I wanted to get some information. We were using a thing called PaperCall, which brought back information about our submissions and our speakers. And I also wanted to get information from Twitter about who the submitters were for speakers who we maybe didn't know much about. And I wanted to learn a bit about them. So I needed to go and get information from my submission site. I also needed to get a Twitter token, auth token, so I could take those two things together and take a list of Twitter handles and my auth token and then go back and ask the Twitter API to give me the information I wanted. But I didn't necessarily care whether the Twitter authentication finished first or whether my call to my submission site came back first. I just wanted them to both go. And when they were both done, do something with it. So the way you do that with the Promise API is pretty clever. But sometimes when you hear clever, clever's not always good, right? So it's neat, it's clever. The way you do this with promises is I can call A and B, right? A and B are promises. I'm not awaiting. There's no await here. So I'm loading two different data sets, and they both return promises. And now I could use promise.all and pass in the array of promises. Anyone use promise.all? Familiar with it? A couple people? Okay, right? So I can call promise.all, pass all these promises in an array, and when they all come back successfully, if they all come back successfully, I can respond to them, and results is then an array of those result sets or whatever it is. But it gets kind of messy. You got to keep track of which is which. You're going to have an array that's in the same order you pass the promises in. I've got to splat it out in some way so I can actually process these things other than with just an array of what is probably another array. And it's just sort of messy. It works. It does the job. It's a little messy. Async await, that just all looks like basically like this. I make an asynchronous function. It looks almost like this. This isn't exactly right. Right? It looks almost like this. So I call load data set 1 and 2, and then I just await processing the data on A and B. Notice, I'm not really running these two at the same time like I was before, right? Because I'm awaiting here and I'm awaiting there. But I can do this, which looks a little funky, but if I don't, even though this is an asynchronous function, if I don't use await here on these two asynchronous calls, they're going to return promises like they always would. So now I have two promises here. So I'm not awaiting. I'm going to go call load data set 1. I'm going to move on. I'm going to go call load data set 2. And A and B contain promises, and I will await them right down there. And only when they're done, here, then I can go and call process data and wait for that result. And it runs synchronously without some of the complication of promise.all, which again, especially here, makes things like error handling and debugging a lot simpler than handling a promise.all debugging situation. Can you see that? Yeah.
In this case, the process the data function itself is asynchronous?
In this case, it is.
But it doesn't have to be.
It does not have to be, right. So in this case, the process, the data function, we're assuming is an asynchronous function as well because I'm probably going out and making another server call to do something. But that's right. Even if process the data was just a traditional synchronous call right here in the same, no remote servers, no async, that would work just fine. I could just call that once A and B are done, but I can let A and B be promises and await them down here. Yeah, that's right. Any other questions? Cool. One other thing about await and async await is that you cannot await what I call at the top. Right? So if you're writing code in, say, the global scope, set aside whether you should be or not, but if you're writing code in the global scope, if this is, say, your entire app.js file, you can't do this. Because you can't use await unless you are in an asynchronous scope, and by default, the global scope of your window, your application, whatever, is not async. So you will actually get, this is the error you'll get anytime you use await outside of an asynchronous scope. You're going to get unexpected identifier. We don't know, you use this word, we don't know what it means. Right? Now, there's two ways to get around that. One, which is maybe the better way, maybe, is you could just use promises in this scenario. You could just use the promise API here. Instead of awaiting it, you could use some async call .then and use the promise API, and there's nothing wrong with that. If you really want to use async await, and if this isn't really your entire app, because I would not do this for an entire giant monolithic application, but if your code is more modular, then you can also use an IFI and do something like this, because IFIs can be async as well. So I can declare an anonymous IFI function here, put async at the beginning, and this will work just fine. But just keep in mind that now the entire scope of this file, whatever this file is async. Right? So again, if this is actually your entire application, you may not want that. But it's a possibility. Any other questions about async await in general? Cool. All right. So a few other things that are this year. These are things that are in the spec right now. There are trailing commas, kind of a minor thing. I'm going to mess this camera up because I'm going to walk across. Let me get my water. And I'll just set it down there. So trailing commas, you could do this in some scenarios. You could say in like arrays and certain things, but what you can never do before is in a function declaration. If you had some function of a, comma, b, comma, c, if you said a, comma, b, comma, c, comma, close parenthesis, on your function declaration, it breaks. Right? It wasn't allowed. Now you can do that. As maybe it should break. However, now you can put the trailing comma. The advantage is, which isn't an advantage I care about at all, but depending on your practices, your source control habits, and what your coding standards are, the real only justification I see for it is if you tend in your code to have your function declarations where you put a property on each line, right? You can do that, and you can add one at the end or in the middle, whatever, and you're not going to have random extraneous changes in your change sets that mean nothing, because it's okay, you can always have a comma at the end of the list. That's the only real strong reason that I see. But it's there. You can do it if that impacts you. Great. If not, please don't put commas at the end of your lists. Descriptors. So you can have property descriptors, right? Every property in an object literal in JavaScript has a property descriptor, like whether it is enumerable, whether that property is enumerable, whether it is mutable. There are ways that you can get individual values of individual property descriptors from an object in the past. There's now an object.getOwnProperty descriptors on an object that will return you a list of all of the properties in that object with all of the descriptors in each of those properties and what their values are. So you can, in one fell swoop, get all that information about your object. And then shared memory in Atomic is kind of a big thing. And it's pretty cool. It's just beyond the scope of this talk. It's in an hour, let alone 50 minutes. But if you use like web workers and things like that, because remember, JavaScript is still single-threaded. Even with web workers, it is still single-threaded. But there's been the rise of a lot of concurrency and parallelism still in JavaScript using things like web workers. And the trouble is, because it's single-threaded, because all those different workers aren't really running in the same process, sharing information between them was a problem. So what shared memory in Atomics what they do, are there a whole set of new features that allow you to take like small little shared byte arrays and buffers and things within JavaScript that you can actually place values that can be accessed from different workers. It's more of a complex thing to go through and is way beyond the scope of this talk, but if you have concurrency or parallelism issues in your JavaScript development, starting this year, these are features you're going to want to start looking at. They may help you solve some of your problems. Now, that's really what was in there this year. Still wasn't a ton of stuff, right? I mean, that includes things like string padding, right? So it wasn't a really huge year, other than maybe async await and the atomics stuff. But ES Next, what we can have next year, right? I don't know, right? Like, I don't know, but we're going to find out that there's a lot of things coming that are pretty cool at some point in the future. For example, rest and spread properties. So we can use the rest of the spread operator for defining properties within our object and getting properties back out of our objects, which would be kind of a cool thing for sort of object models and definitions in our code. Things like async iteration. This one is really cool. Remember, this is all new stuff. This is stuff that's not in the spec today. These are not things that are in the language, but they're things that are on the horizon. Async iteration is take the iterables, take like the for each type stuff we can do, and take what we have with generators and with async await now this year, and you can take something where your actual iterant in your for each loop can be itself some sort of an asynchronous call, or something like a generator. So we can go out and say, okay, I want to do a for each loop over something, but this thing is in fact an asynchronous call on its own, and you can have an await inside your for each loop, so now when each value comes back, then go through the loop again, similar to the way generators are doing things. So that's going to be really cool. Regular expressions, you either love them or you hate them. Like you either really love them or you really, really hate them. I tend to love them. If you use the regular expressions and you like them, there are a variety of enhancements coming for how we can define patterns in regular expressions in JavaScript. There's a whole bunch of stuff coming there. My favorite, because we have classes in JavaScript. At this point, it's been a few years, and I guess I have to accept that we have the class keyword in JavaScript. I don't believe in classes in JavaScript. Now, when I say I don't believe in classes, I kind of always say, like, I mean that in the same way that I don't believe in unicorns and dragons. Like, I don't believe they exist, right? Not like I don't believe in whether you should use them. Like, they're not a thing. It's a keyword that wraps around some syntactic sugar around prototypes because JavaScript's still a prototype language, right? They're not classes. One of the problems with using them, though, is access modifiers. Right? One of the first problems I encountered right away when I started trying to, a couple of years ago, take some AngularJS code and start using classes in them to see how that would kind of play out, was there was no private fields in my classes. Right? There was no access modification to anything. So they're fixing that. This is getting more attention than any other proposal in the language right now. I get 10 emails a day on what's happening with classes and their properties and whether we should, and how we're going to add private and public fields, and how the syntax should work and how they'll be implemented. This is a big thing. It might almost, sort of, someday, maybe, get me to consider using classes in JavaScript. And for me, that's a big thing. But I don't know when any of this stuff is coming. Right? We're almost through 2017 now. Right? It's mid-November. 2018 is right around the corner. That and many other things, I don't know when any of that's coming. So I always am slow to share that information because a lot of people probably come in and say, yeah, I'm going to hear what's coming in 2018. And if I start the talk and I say, I don't know what's going to be in the spec next year, you're all just going to leave, right? But I don't know. However, we can make educated guesses. Right? I have a decent idea of what I think will come. To kind of get a sense of that, now we're going to kind of have a history lesson. We're going to kind of take a little trip in the Wayback Time Machine. And we're going to go back to 1995. So back in 1995, this guy, anyone know who this is? Anyone who, I know you do. Anyone know who that is? This is Brendan, yeah, it's Brendan Eich, okay? Brendan Eich, back in 1995, was hired by these guys. Remember them? Yeah. See, this is my favorite slide of the whole thing, because I can age, like I can kind of timestamp everyone in the room, because if you were me, like, yeah, Netscape, I know that you're at least like around my age and not a lot younger than me. Okay, so Netscape hired Brendan Eich to come in and build a Java-like scripting engine for adding advanced functionality to the burgeoning like infant web. So in May of 1995, in like a famous caffeine-fueled 10 days, he very infamously built JavaScript 1. JavaScript, not ECMAScript. There's no ECMAScript. JavaScript version 1. It was released, I think, with Netscape Navigator 3 Beta 2, or something like that, in the fall of 1995. It had lots of problems. Maybe because he wrote the language in 10 days, right? There are some problems we still deal with today because he wrote the language in 10 days. But, on the other hand, these guys took notice. And within a year, IE, oh, it was Netscape 2 Beta 3, I think it was IE3, I think, is when JScript came out. Anyone remember JScript? Couple, right? JScript really truly wasn't JavaScript. Like, it wasn't. Right? And that's the thing is when I say, remember that very early slide in the talk when I say everything works differently in different browsers, JScript was just a different implementation. They literally reverse engineered JavaScript and built something similar for their browser. This is still in the time when patents with software are somewhat in their infancy, and so it wasn't necessarily quite as much of a legal problem when they said, yeah, we're just going to rip this thing apart, figure out how it works, and then build it for our browser. So they did. Now, a couple things happened as a result. First of all, this is sort of the beginning of the browser wars, which happened for years, all through the 90s and early 2000s, led to massive class action lawsuits for antitrust in the United States and other places around the world where Microsoft had issues. They were packaging with Windows 95, IE, and all this sort of stuff. A lot of that came about because of this. Also, Brendan Eich and his buddies at Netscape, who now have also, since in the year that's happened since he wrote the language and now, have also gone on to found Mozilla. The two of them, the two organizations started figuring out, wow, we're onto something. Like, if Microsoft wants to steal your technology, then you've made it, right? Like, if they're ready to do what you're doing, then things are going well. So they figured that they needed to figure out how to make sure that the language survived without too much fracturing. So they submitted it in late '96 to ECMA International. Now, ECMA used to be the European Computer Manufacturers Association. It is not anymore. People from this side of the Atlantic Ocean may already know that. People in the United States have no idea, so I just always make sure that they recognize. That's where the name came from, but it's really just ECMA. And ECMA is a standards organization, just like, say, ISO. They do a lot more than ECMAScript. There are ECMA standards for, there's one for .NET. It's way out of date, but they're working on it again. There's ECMA standards for hardware, things like floppy drives and CD-ROMs. Like, they're a standards organization. So what happened is Mozilla submitted the language to these guys, say, can you figure out what's going on? They worked on it, and ultimately the result was they came up with something called ECMA 262. That is ECMAScript. In 1997, ECMAScript version 1 was released in '97. The idea was, here's the standard. You guys want to write JavaScript, you want to write JScript, you want to write ActionScript, right? Which is also a flavor of ECMAScript, right? Like Flash was really just sort of a flavor of the same thing. If you want to do that, that's great. Here's the standard you should follow. And they had a release 3 years in a row. 97, 98, 99, there were 3 releases. It was done through this organization, through this group called TC39. Anyone heard of these guys before? Anyone, right? TC39, a lot of times you hear them say TC39 committee. The C stands for committee. So it's just the technical committee number 39 at ECMA. Their job is that they maintain the standard of ECMAScript. That's what they do. When a new version, where we're looking at ECMAScript 2017 features, is these guys who put it together. Now, the members are organizations like this, and they don't always get along, right? It's all the major stakeholders originally in the web and now the other places that JavaScript is important in the world, which seemingly more and more is everywhere. And these major stakeholders all send representatives, and they all get together, and they should talk and work things out and add features. Yeah? There has been someone from Apple in the past. I don't know if there's someone there right now. It's more than these 5. I don't know if there's, do you know if there's someone, John, from Apple right now? I don't think there is currently. I don't think. There has been from time to time. There have been other organizations that have fallen off over time. It's just sort of people come and go. They're all member organizations of ECMA, however, and they're people or they're groups that seem to have a major stake in the web. So, thing is, sometimes they argue, and sometimes they argue a lot. And when they argue a lot, nothing gets done. So after 1999, nothing happened until 2005. Because by then, the lead engineer for Internet Explorer and Brendan Eich started fighting constantly, and they hated each other, and they wanted nothing to do with each other. And so ECMAScript 4 never even happened. Then there was like an ECMAScript 4.1, which sort of kind of happened. And eventually we had ES-Harmony, right, which you may have heard about several years back. And they called it that because it's like, let's come back to the table and have some agreement again. And they had a release in 2009. And then guess what? For another 6 years, they fought, and nothing happened until we had ES6 in 2015. So there's a problem here. There's a problem here, which is that, first of all, the web is advancing quickly, right? Like HTML, CSS, those kinds of things are happening fast. JavaScript was happening slowly. So not only did it have all the problems that it had anyway that are just baked into like the nightmare that is sometimes working with JavaScript, but also the web was getting ahead and JavaScript couldn't keep up. That's one issue. And the other issue is just when they did have releases, like in 2015, it's so much stuff that nobody can consume it all. Right? You get so many new things that it's like a whole new language and everyone's starting over from scratch. So after 2015, TC39 said, we're going to have a real process. We're going to really have a process for how things should work going forward. And because of that, we will have a release every year. That's why we've had a 2016, a 2017, there'll be a 2018. The idea being there will be smaller, bite-sized chunks of features. They may be major features, they may be a big deal, but there will not be 30 major features coming out in a given release, because if something doesn't make it into 2018, it can come in 2019. So the way that works is every single proposal, every new feature starting 2 years ago has to go through the same set of stages, no matter how big or how small. Async await, classes, string padding. All go through the same set of stages to go from inception to part of the language. When we go through them, this is sort of like standardsy stuff I know can kind of be dry, but the things when we say, what is going to happen in 2018 and 2019, how do we know? It's because we can pay attention to this. And we'll see how in a minute, to get an idea of where things are going. So all of us together can look and follow the community and see where we think TC39 is going, so we can get an idea of what proposals might be coming to the language and how soon. So the stages go from 0 to 4. The first stage, stage 0, which I always think is really weird, by the way. This is just as an aside. 0 is like one of these numbers, like even though we have 0-based arrays and stuff, like 0 is usually not the starting point for counting things in the United States. Like you have the 0 floor. We don't have that in the United States. Like the ground floor is 1. So it's very strange. So for the first, I'm like, oh yeah, of course it starts at 0, because I've been over here for 2 weeks. So stage 0 is what they call the straw man stage. It's not a thing at all. It's a simple entry point. All that's happening here is someone with an idea who has access and rights to TC39 is saying, I've got an idea. I think we should do this. I'm just throwing it out there. Tons of things get added to the process at stage 0 that never go anywhere. Tons of ideas. Some of them very good ideas that just never gain traction, but it's a starting point. It's a place to say, I have this idea, I want to throw it out there for discussion. Because TC39 meets every 2 months in person. So it's kind of a place for them to sit down and talk. Now stage 1, which we call the proposal stage, signifies that TC39 as a group have looked at an idea and they say, yeah, that idea is good, we like it, we think it warrants real discussion, and we're going to agree that we're at least going to give this some serious consideration as an organization instead of just leaving it where it sits. During stage 1 of the proposal, a couple of things happened, mostly around documentation, but simple documentation, right? What is the problem we're trying to solve? Well, this guy had left pad and he went away and everything broke and we don't know what to do, and wouldn't it be easy just to add padding to strings in the language, right? Here's the problem, solution, and what challenges we might face, both technically or from a business or practicality standpoint, what challenges there might be. We're just trying to define that. The other thing to be stage 1 is that someone on the committee has adopted the proposal as its champion. Because after all the fighting between 1999 and 2015, with all that fighting, they figured that design by committee wasn't working. Right? So, yeah, we have a committee, but we need someone to shepherd this thing through. Okay. Stage 2 is the draft stage. What happens during the draft stage is we're starting to actually put together the feature. We're doing things like polyfill code. Right? We're writing things to say, how is this actually going to work? How is this feature going to come? How's it going to look and feel? How's it going to function? And we start drafting the actual spec language because remember, ECMAScript, ECMA 262, is a formal standard. So we start kind of drafting out some of the language about how this feature needs to be documented. Okay? We start doing that. Some of the semantics, but nothing too formal, just going through the process and getting a feel for what might happen. We get past that. I don't know if anyone watching me. How are we doing on time, by the way? Anyone have a time? I'll grab my clock. Okay, that's great. Perfect, thank you. So, candidate stage, right? The candidate stage is, okay, it's gone well, we like it, we're actually finalizing the specification, okay? We know we want to move forward. When you get to stage 3, what we say is, you can't go any further. This is as far as we can get without having real-life implementations. So now, what happens during stage 3 is we go out to at least 2 stakeholders out in the real world, say the Chrome team, the Edge team, the Safari team, or whatever, the Node team, at least 2 real-world implementations building the feature to get real-world feedback to see how it works. Without that, it doesn't make the spec. And if it survives that and tests out, then it reaches stage 4, which means it's finished, and it will be released in the next available release. So basically, at the meeting in January that's coming up, anything that reaches stage 4 by the end of that meeting will be part of ECMAScript 2018. Anything that is not, isn't. Right? So, what do we do with that? So what? How do we predict the future? Because we only have a few minutes. Because this is kind of how we can now take that information and do something with it. Right? Because the problem is there are so many proposals in the language. There are tons all the time. Tons of proposals. However, it's all being done in the open. All of it's being done in the open. Yeah, it's all open source. The spec is open source. I mean, you and I cannot submit contributions. Like, I can't do anything with it, right? But it's all out there. It's full transparency. So TC39 has a GitHub organization with a repo, ECMA 262. That's like a landing page. But there's more. This is just sort of where you start. Yeah, get this one, because if you start here, there are links through this repo, a bunch of readmes that take you through a bunch of other options. So, for example, there's a sublist. Finished, meaning stage 4. Stage 0 proposals. A list of any of the active proposals, which are stages 1 through 3, and even something that gets dropped on the floor partway through the process. They still keep it around. And every single proposal has its own repository with its own polyfill, its own test code, its own discussions, its own issues being opened. And you can get notifications from GitHub on any one or more of these things. So, for example, the private and public fields stuff about classes, I get 10 emails a day on what's going on, but I can see what's happening with it and see how the discussion is progressing. So I have an idea of, is this thing going to make it in, or am I waiting another year? Right? So we can have a better idea of what might be coming based upon how the discussion proceeds, because you can see what's happening. Additionally, this guy, Rick Waldron, who is a representative member on TC39, has his own repo of notes. I don't know if he's officially the secretary or not, but I don't know, but of the organization, but he takes very detailed notes of what everyone is saying on the committee about every proposal every time they meet. And it goes back a long time. So you can go and read these notes and review what's happening and get an idea of what's happening and who's doing what and figure out kind of what's being discussed in these meetings. So you can get more information. And lastly, if you want to play with things, or pretty much lastly, is this slide was shown yesterday briefly, I think, or maybe you didn't actually show it. People familiar with KangaX? You seen this thing before? Anyone seen that site before? A few of you, yes, like a lot of no's, okay. This is a site that shows every feature that's out there right now that's being discussed, and every current build of various runtimes and environments for ECMAScript, JavaScript, what have you, and where it's been implemented and where it has not. So for example, this is an older screenshot now, it's from several months ago, but here's some of the 2016 and 17 features. There's a lot of green. There's some no, but there's a lot of green yeses on environments where these things have been built. If I click on next at the time, there's a lot of red. But you'll notice because things that are in stage 3, like the object rest and spread properties, async iteration, since they still have to have at least 2 real-world implementations to get to stage 4, there are teams that are building these features. So if you want to see how they work, you can test them. Right? And then, here's a bit.ly for this, for that screen if you've never seen it, or if you don't know how to find it. It's just bit.ly It's an older thing from when it was an ES6 talk, but ES6-compat. Okay. And the last thing, very last thing, is Discuss, ES Discuss. There's an old Mozilla distribution mailing list that goes back a long, long time. That's an open list that has, just like mailing lists, emails, where you can see a whole long list of forums and discussions going back for a very long time about all this sort of thing, so you can start to identify trends, see how things are going, right? The point of all of this is just like, you can educate yourself, right? Because I can't tell you what it'll be in next year or 2019 or anything else. You can educate yourself about the process and how it works, right? You can invest some time in it for yourself and for your teams, right? So that you can get a better idea of what might be coming, because once you sort of know that, then you don't have to be so anxious about what's coming in the future, and you can just sort of focus on going out and focus on making incredible software and not worry about the minutia of when's this thing coming, when's that thing coming. You just go out and make awesome software. So, I think I ran like 1 or 2 minutes over. Let you guys go. If you need to reach me for any questions, because we are heading to the airport at 4 a.m. tomorrow morning to fly back to the States, which is going to be great. But at Jeffrey Strauss on Twitter, here is an email address, and if you want a further discussion or you have questions at all about any of this stuff, you want to talk about it, if you use the JS Futures hashtag, I will see it, I will respond, we can have a dialogue and discussion even after I head back to the States. Thank you all very much.